Hello all, welcome back to the series of data structures using Java. In the previous video, we discussed about implementing a single linked list. So in that we have seen some of the operations like creating a node, then searching for a data value in the list, and then for finding a list whether it is empty or not. Then we have done traversal. Also, we have seen how to find the length of the linked list, right? And now in this video, we'll be discussing about insertion operation in a single linked list. So coming to insertion can happen in three ways in the single linked list. That is insertion at beginning, insertion at end, and insertion at in between. So first we'll see how insertion at beginning is happening. So let us take, this is my new node which I want to insert into the existing list, and this is the existing list, right? So I want to insert that node in the first place of the list, that is at the head position. So how do I basically insert it? If you see here after insertion, so how is my list? So now 10 is inserted in the first position and head is pointing to this node, new node, that is 10, and the node that having data value 1 is at the second place, whereas it has third place and it went to fourth place. So this is how insertion at beginning happens in the singly linked list. That is, this node gets inserted in the first place. Okay. So what are all the changes we are doing to insert a node at beginning? Okay. If you look at this node, first, whenever you are performing insertion operation, you need to create a node first. Okay. That is the basic thing you need to do when we are when we are inserting a new node. So here I have created a new node, and what is the data value of this new node? 10, whereas coming to the next field, always the next field data value should be null for a new node. So this is a new node and this is the memory location of the new node. You do not know what is the memory location of the new node. So for example, temporarily I have taken it as G, right? And this is my existing list, okay, where the first node is having the data value 1, and what is the memory location of that first node? C. Okay, and this first node is referred as head node. Now I'm going to insert a new node into this list. So what are all the changes I can do here is, first I need to change this memory location, that is link. Okay, I need to change this link of my new node. So what should be the link of my new node now, right? As you're going to insert this as the first node, and this node will be referring to this node next, right? So what is the memory location of this node? C. So you need to replace this null with C. If you replace this null with C, automatically a connection gets established here. Okay, so now this node is pointing to this node, right? This is the first change you have done. What is the one more change you need to do? See, now this becomes the first node of my list. So always head should point to the first node. But where is the head? It is pointing here. You should change that first. Okay, you should change it first. So now this node should be my head node. Okay, so here you need to do two changes. One is changing the link of your new node, and the second change is you need to change the new node as your head node. Okay, these two changes you are doing here. How do we write it in a code? Okay, if you look at the code, you can see I want to insert the node at first, that is at beginning. Okay, so whenever you are inserting a node, first operation is create a new node. Here I have created a new node by this call. You can see that I have created a new object for the class node with the reference new node. So new node is my object reference, and you can see here you are going to pass some value, data value here. What is my new node data value? 10. So I am passing 10 here. I can pass 10 as the data value. If I pass 10, a new node will be created with this data value 10 and having the next value, that is null. Right? So after creating the node, you can see what I have done here. My new node, okay, this is my new node. First I changed the next field of my new node. So new node dot next field of new node. What is the next field of new node I assign? I assigned whatever is there in the head node. So you can see head node is pointing to this node which contains the address C. This is the address of this node which contains the address C. So this address should be given to where? New node dot next. So that is what I have done here. New node dot next is equal to head, which means now head address will be given to this new node pointer. Okay, so after this, what is the next change we did? We have changed the head from here to here. Now my new node will be the head node. So you are assigning head node as your new node. So that is what the second line here. So you are assigning head node as the new node. If you do this, then this will be your list after insertion. This is about insertion at beginning. Next is insertion at end. So how do you do insertion at end? Again, when you are performing insert operation, you need to create a new node. Here I have created a new node with the same data value 10 and the next pointer is pointing to null. Okay, and this is my existing list. If I want to add this new node at the end, because this is insertion at end. So if I want to add this new node at the end of my list, so how do I add it? What are all the changes I need to do? See, if you look at this existing list, the last node is actually pointing to null because we know that this indicates the end of the list, right? But now if I add the new node here, then it shouldn't point to null. It should point to my new node only. Okay, so you need to assign this value, that is last node value. Okay, you need to assign this last node next value that should point to where? My new node. What is the address of my new node? That is G. So instead of null, you have to replace it with G. If you replace it with G, then automatically a connection will be established here. Okay, so only you are going to perform one change in this, that is you are going to change your last node address as new node, that is your memory location of new node G, right? If you do that, automatically this will get connected here. So this is the list after insertion. Now how do you write a code for that? Okay, so we'll see the code. Here is a code. First step, as usual, you are going to create a new node. Okay, and the data value here is 10. And if you look at here, what am I doing here? I'm checking whether my list is empty or not. Okay, because if you have any elements into the list, if you have nodes in the list, then you can do all this process. What if my list is empty already? Okay, what if my head is pointing to null already? Then what I have to do? Just I need to do only one step. What is the step? My head node should be pointing to my new node. Okay, if the list is empty, if my head node is pointing to null, then what I need to do? I need to assign this new node to my head, so that my head node will be pointing to this new node, right? So this is when my list is empty. So that is what the condition I'm checking here. I'm checking whether my head is equal to null. If the list is empty, if it is true, what I'm doing? I'm assigning my new node to head directly. Okay, if not, okay, if your head is not equal to null, which means if your list is not empty, then what you need to do? First you need to find the last node of your list. How do you find the last node of your list? Again, you need to perform traversal. Okay, so starting from the first node, you need to move to the next node. Again, you need to check whether the temp is null. If it is null, stop here. Otherwise, again move to the next node. Again, you need to check whether it is null. If it is not null, move to the next node. Now here you are checking whether it is null. Yes, it is null. So stop here. So until like this, you need to do what? Traversal. You need to find the last node. Okay, you need to find the last node of the list. So here you can see I have done the same. So I'm taking a node, okay, that is a temporary node, and the name of the temporary node is current. Okay, and I'm assigning my head node as the current node. Okay, now my head node is also what? It is called as a current node. In the previous example, I have taken the name temporary, temp, and here I have taken the name current. Okay, just I have changed the variable name. You can use whatever the variable name you want. And now this is my current node. So what I'm doing, I'm going to traverse through the list. So for traversing the list, I'm using iteration, that is while loop, until my current is not equal to null. You're going to traverse. Okay, so how you're going to traverse? Current is equal to current dot next, right? So if you do like this every time, whenever the loop is executing, so first this will be the current node, again it will move to the next node, again it will move to the next node. Okay, so once by this you will find your current node, like, right? So once you found the current node, what you have to do? You need to assign your new node to the current dot next. Okay, if my current node is this one, right? If my current node is this one, then in the last, that is in the next pointer, okay, current dot next, what I'm doing, I'm assigning my new node so that this new node will be joined here, okay, gets connected here with this list. This is how you need to perform insertion at end. Then we'll see insertion in between. Okay, so how we are going to insert a node in between. Here for in between I have taken, I'm going to insert a node after some node value. Okay, for example, this is my list. I need to insert a new node. This is my new node with the data value 10. Okay, I want to insert this new node somewhere in the list after some node value. That is, for example, I want to insert this after 2. Okay, after this node containing value 2. Right, so in that case, how you will insert and what will be the structure after insertion? So this is the structure after insertion. So after 2, okay, you can see after 2 and before 3, my new node gets inserted, that is 10. Okay, and what are all the changes we need to do here when you want to insert a node in between? Okay, 2 changes you need to do. One is changing the next pointer of this node. Okay, because currently this node is pointing to this node, but when you are trying to insert a node in between, then you need to change this pointer. Okay, this pointer value should be changed first, and next pointer value is this one, because my new node is pointing to null now, but you have one more node after this when you inserted it in between. So this node, instead of null, it should point to my next node, that is next node of 2. Okay, so this is what you are going to do here when you are doing insertion in between. So 2 changes, one change is here in the previous node and the next change is in my new node. So for this reason, again what you need to do, you need to traverse the list to find first where that node is. Okay, after which node I want to insert. So you have to find that node. So in order to find that node, again you need to do traversal. Starting from the first node, you need to do traversal until you find the node after which I want to insert my new node. Okay, so here also along with traversal, what you are doing searching. So what we did in the searching along with traversal, we also did the comparison. Okay, so you are going to compare this data value with the after node value. Okay, that is the node value. After that you are going to insert some node, right? So you need to compare this value and the node value. For example, if I want to insert after 2, I need to compare, is this my node having value 2, right? So that's what I'm going to do here. First I need to traverse, along with the traversal I need to do compare operation. Okay, comparison. And one more thing I have added here is, see, if I am inserting a new node here, okay, this will be my new node, that is current node. Okay, this will be my current node which I'll add, but I need to change the previous node data also, that is previous node next field also. So for that I'm going to take one more node called previous node. I'm assigning that node as my head node. Okay, so I'm taking new variable that is called previous node. I'm assigning that as head node. Okay, now I'm going to traverse with this previous node only. Okay, you're going to check whether your previous node is not equal to null. If it is not equal to null, you are comparing previous node dot data is equal to data. So if it is equal to data, simply you are returning. Okay, because you found the node where you have to insert the new node, the position you found, the node you found, so you are returning simply. Otherwise what you need to do, you have to move to the next node. So for moving that, you have this one, previous node is equal to previous node dot next. You are moving to the next node. Okay, this is how you are trying to find the position where you want to insert. Okay, so once you found the position, what you are doing, you are creating a new node here with the data value 10. So a new node will be created. After that, what you are doing, you need to check for the previous node. Okay, then this previous node dot next. See, I told you the new node should point to what? Point to this node, that is a node after this node. This new node should point to this node. And where is the address of this node stored? Okay, previously before insertion, where is this address? If you see here, this address is here, right? And what is this node now? This is my previous node, right? So we have traversed till here and you found the previous node. This previous node is containing the address of this node, and where this address needs to be changed, this address needs to be changed here, updated here. So now new node dot next should be updated with what? Previous node dot next. Okay, so that is what given here. New node dot next is assigned with what? Previous node dot next. Okay, so after assigning that, now you need to change the previous node. So what previous node should point now? It should point to your new node. So previous node dot next should be assigned with what? New node. So that is what given here. Previous node dot next is assigned with what? A new node. Okay, this is how you are going to perform insertion after some particular node. How we are going to find that particular node? By traversing. And you are not just traversing, also you need to compare the data value of each and every node in order to find that particular node. So this is all about insertion. Insertion at beginning, insertion at end, and insertion in between, that is after some node. Okay, so then in the next video we'll continue deletion.